Hello everyone, and welcome to your video which is going to talk about domain and range calculations. Now, there are lots of fancy ways that you could define the domain and the range, but we're going to keep it simple. We're just going to say that the domain is talking about all of our x values, and we're going to say that the range is talking about and the range is talking about all of our y values. And the way I remember this is, see how the G in range drops down below the line and the y drops down below the line? Those go together. Nothing drops below the line in domain and nothing drops below the line in x. So domain and x go together. So that's how I keep it straight. You don't have to, you could think of a different way to keep it straight, but that's how I do it. So domain is x values and range is y values. And what we're talking about here is that sometimes, depending on what your formula is, your domain or your range are limited. You're not allowed to have certain numbers for your x, or you're not allowed to have certain numbers for your y. Let me show you what I'm talking about. Let's take a nice simple equation. We'll have f of x equals x plus 2. Now, you know that f of x is the name of our function, and that's really just talking about our y value. So when we're talking about the range, we're talking about the y values, and we're talking about this, f of x. When we're talking about x, that's our x value, and that is dealing with the domain. All right, so before we talk about domain and range too much, let's make ourselves an xy chart. So I make it a little bit fancier now. I put the actual equation over here because it's getting harder with functions. So let's pick some nice numbers for x. And I just randomly selected, I said, okay, we'll make x negative 5. So then this would become negative 5 plus 2, which is negative 3. And what if I picked negative 2? Well, that would be negative 2 plus 2, which is 0. What if I picked 0? Well, that would be 0 plus 2, which is 2. And what if I picked 8? That would be 8 plus 2, which is 10. All right, and that's enough to make me happy. Again, I just picked these numbers because they were the ones that floated my boat when I wrote this XY chart. You can pick different numbers if you want. Okay, so let's plot this graph. So we have negative 5, negative 3, negative 5, negative 3. So that's here. And I have negative 2, 0, so that's here. And that's really enough for me to draw a line, right? Because this is going to be a straight line, so no problems. Let's keep going, though. Let's do 0, 2, 0, 2, that's here, and 8, 10, 5, 6, 7, 8, 10. So we're going to get a straight line that goes like this, okay? Now, here's my question to you. Could x be any number? So we have examples of x being negative, and we have an example of x being 0, and we have an example of x being positive. So I'm pretty confident that x, anything that we put for x, we could put into this equation and we would be fine, right? So I'm going to say that my domain, which is my x value, has no limits. So it can go all the way from negative infinity to positive infinity, right? And this is interval notation. I put the parentheses here because it never actually touches negative infinity and it never actually touches positive infinity, right? But my x could go from way over here all the way to way over here and it would be fine. My range, which is my y value, could it be anything? Well, yeah, here we have a negative y, here we have a 0, Here we have some positive y's. I look at my graph and I think any number that I pick, even if I pick like 572, I will eventually have a y of 572. I would also have a really big x, but that's okay. So my y value is also unlimited. It can go all the way from negative infinity to positive infinity. So this would be an example of a completely free function. You could put any number in for your domain and you have an unlimited range of output, so there are very few restrictions. That is not true for all functions. Let's look at a different function. It's a similar function. So we'll do f of x equals the absolute value of x plus 2. Now already you should be thinking, I bet that absolute value symbol means something. It does. What does the absolute value symbol mean? It means that you cannot have a negative number, right? Because if you put like a -5 in for x, the absolute value is going to force it to be a +5, right? Where shall I write this? I'll write this down here. So absolute value of -5 is +5. Absolute value of -2 is +2. Anytime you put a negative number in for x, you're going to get a positive number back out. Does that make sense? Okay, so that means that, well, you'll see what that means. Let's make our XY chart. All right, so let's use the same numbers as before. We used -5, -2, 0, and 8. Those were our 4 numbers that we used. So if we use -5 here, that's going to become a +5 plus 2, which gives me a 7. If I use a -2, that's going to give me 2 plus 2, which gives me 4. If I use a 0, that'll be 0 plus 2, which gives me 2. And if I use an 8, that'll give me 8 plus 2, which gives me a 10. All right, so let's see what we have here. I'm just looking. I did the calculation wrong a moment ago, and so I just wanted to double check to make sure that I did it right. All right, so -5, 7. -5, 7 is right here. -2, 4. -2, 4 is right there. 0, 2 is right here. And 8, 10. 8, 10 is right here. Oh my goodness, what is going on? Well, I'll tell you what's going on. What's going on is we are going to have a graph that looks like this. We are going to have a graph that looks like this. And if you don't believe me, you can go ahead and fill out more x's and you'll see that that's exactly what's happening. For instance, if I said, okay, well, what if we make x equals 2? Well, then that would be 2 plus 2 equals 4. And 2 and 4 right there. Okay? So we're going to get this V-shaped graph, and that is going to mean something for us, isn't it? What does it mean? Well, it means that our x's, our x value, which is our domain, can be positive or negative, right? Here we had some negative x's, here we had some positive x's. You see that we're over here. So our x values are not limited. That is still negative infinity to positive infinity. Our range, however, is limited. What is the lowest that our y value ever gets? The lowest it ever gets is 2. And it does get exactly 2, so I'm going to actually put this into a bracket because it could equal 2. But 2 2 is the lowest that our y value gets. How high does our y value get? Well, that can go for forever. So that is the interval notation for our range. Notice our range is limited now because of those absolute value signs. Here's another way to think about it. If you take the if you take x is always, because you're taking the absolute value, this is always going to wind up being a positive number, right? Because once you take the absolute value of something, you get a positive number. So if you take the smallest number you can get without it being negative, that's 0, y is going to equal 2. And so since x will never return anything lower than 2, since x will never return anything lower than 0, y will never return anything lower than 2. So 2 is as small as it gets. So for these types of problems, you might find it very helpful to draw your graph first and then start to think about your domain and range limitations. Let's do one more. Let's do this one, and for this one I'm going to give us a similar but not identical problem. Here I'm going to give us x plus 2, the absolute value of the whole thing. And again, when we do our chart here, I'm going to pick those same numbers. So -5, -2, 0, and 8. So when we stick a -5 in, that's going to be the absolute value of -5 plus 2, which is the absolute value of -3, which is +3. X, if x is -2, then this is going to be the absolute value of 0, which is 0. If you put 0 in, that's going to be the absolute value of 2, which is 2. And if you put 8 in, that's going to be the absolute value of 10, which is 10. Okay, let's put this on the graph. So -5, 3 is about right here. -2, 0 is about right there. 0, 2 is about right here. And 8, 10 is about right here. So again, we are getting a V-shaped graph, which, by the way, is what you'll always get when you're dealing with absolute value, right? And now let's take a look at the domain and range. First of all, is there any limit to what we can say x is? Your answer should be no, there is no limit. I could pick a positive x, I could pick a negative x, I could pick x is 0, I can write stuff over here in the negative x world, so my domain has no limits. So negative x all the way to positive x, and we're good. How about the range? Is the range limited? Well, yes, you'll notice that it bottoms out here, right? My y value bottoms out at 0. It cannot go below 0 because we're taking the absolute value of it. So the lowest my range can get is 0. It can actually touch 0, so I'll use a bracket. And then the highest it can get is it can just keep on going. So that would be positive infinity. Okay, so that's it for domain and range calculations. It does get more complicated, but this is your introduction to it. So what you're asking yourself is, am I limited with what I can put in for my x value? And am I limited with what my y value ends up being? Okay, we'll do more practice with it. Good luck.